Hey guys, this is a rework of a few videos I did on failover. So dynamic failover if you've got two or more network connections, internet WAN network connections in particular, and you want to automatically fail over if one goes down. In my videos I did, they were focused on one was a recursive routing one, which is fine, it still stands, but the others were using scripts, and they were using it to determine whether there is actually internet access out of one of the networks, and if that fails, so it could happen anywhere between the actual network itself, the interface itself, and anywhere along your ISP's network, because you can always monitor on IP an interface on your device, but you don't ever know what's happening on the network. So your interface could say it's still up, but it wouldn't necessarily show that the internet access is down. And even though there is a gateway feature, if you have a static route in MikroTik, that's only going to ping your next hop. So if the hop here fails, that's all well and good, but if that doesn't and it's somewhere else along the way, then you're never going to trigger that failover, and you're still going to be trying to route out of an interface that doesn't have access. Okay, so with that being said, I developed a way of doing it using scripts, Netwatch, and a scheduler, which I'm going to try and explain here. Now, once I've explained this, I'll explain why I'm remaking this video and the reasons I felt it was worthy of redoing it. So basically, the way it works is we have Netwatch, which is I'm going to assume that you know what these tools are. Basically, they're tools, and I'll show you. We're going to go through the full config, so I'll show you and explain as we go. But Netwatch is basically a very simple way of testing. It can do pings. It can do various other ways of testing connection. But what this is going to do is going to ping Google DNS. If that should fail, basically it will ping it I believe they've got it set to every 10 seconds. Now, if that loses a single ping, then what's going to happen is going to run this script. Now, the reason it's running this script and it's not going to go ahead and change my default route directly is because stuff happens on your network. You could be going over a wireless link. You're going to lose an odd packet here and there, which you'll probably never notice on your network. But you don't want it to trigger your failover every time, and you'd be bouncing back and forth between connections. So for that reason, we run the second script. Now, this script is going to ping the same network again 10 times. And if it gets a full 10 failures, it will assume that that network, that interface, has no internet access because it can't reach this. And this is a fairly trusted source. I mean, chances of that going down are very highly unlikely. So not impossible, but highly unlikely. So then what that does is it's going to trigger a few things. Firstly, this is going to get turned off because what we don't want it to keep doing is testing this way, because otherwise it's going to keep coming up and down. If it's the reason I do it 10 times is because I want to actually make sure it's definitely down and it's not just an intermittent, so we're not again flip-flapping all the time. So this is going to get turned off. This is going to enable this scheduler, but before it does that, it will update the default route. So what I've got is two routes. One has a distance of 2, which is my backup. My primary has a distance of 1. What it's going to do is it's going to set this to 3, so it becomes less preferenced over my second route, so we don't actually make any changes to my secondary route. So at the time of a failover, we're going to have two default routes, one, and they're going to be distances 2 and 3, and there won't be any with distance 1. So yeah, that's going to change that to be 3. But yeah, then what it's going to do is enable the scheduler. And what this scheduler is going to do is then going to be running this second script here continuously every 10 seconds, which we can see if we go to the next slide. So yeah, this has been turned off. My route distance has changed to 3. So my scheduler is now running every 10 seconds, and it's running this script. This script is doing pretty much exactly the same as this. But what happens this time, if it gets 10 successful pings, we move on to the next one. It's then going to disable that scheduler. It's going to re-enable that Netwatch, and it's going to set my default route, and it's going to update it back to 1. So then we get back to the initial state. So scheduler is now back to being disabled. The scripts never get disabled or enabled because they only get run when they get triggered by something else, by these two guys here. And then when our route is back to 1. Okay, so hopefully that's clear. So this is the original video I did, and then I did a secondary one using dynamic gateways, because this one was assuming that your default routes were statically assigned, because there's a few quirks of the scripting about how you update those routes. So then I had a secondary one about that. Now, some of my followers attempted to run through some of this, and they came across a few issues. The first one being that I was initially, when I developed this, I had my primary and secondary pinging Google. Now, I had individual static routes for each one of those with the same distance pinging out of. So the idea was that it would be checking out of that interface itself every time. And when you failed over, if you have that static route set to going out of 1, and the interface is up, your traffic to that 8 to 8 to 8 to 8 was always going to be going out that number 1 in that failed over. So I had the secondary one in there. What that was then doing was preventing the failback. So when I developed this, I'd actually removed that section, but I still included it in the actual video. So that was an error. This is, by the way, this is a website that I have, and I have my guides that follow along the videos that I make, just because it's sometimes easier just to copy and paste stuff from here or run through it at your own pace. So what I've done is this one here I've updated. So I've called a number number 1 and number 2, part 1 and part 2. Basically just depending on the type of WAN interfaces you have, but everything else is pretty much the same. So we have dual NAT rules, so we can able to masquerade out of each interface we set. The routing, this is where we would have our static routes. As you can see, our secondary one has a distance of 2, and then this is the scripts. Okay, so I've got rid of the additional 2 individual routes going out of each interface to Google DNS. So that's gone. That's fixed it. One other thing that someone picked up on was, so the Netwatch runs, it then detects a failure, a down. It then runs the script, and what it was doing, it was then running the script, but it wasn't actually turning itself off. So whilst that script's running, Netwatch potentially could be still checking in the background until, even though it was set to disable in the script, it would only disable once the check script had actually finished and done a failover. It would then disable it. So I tried adding the disable feature at the very beginning of the script, so it would disable it straight away, but still, until that script had completed, it wouldn't ever disable it. So what I've now added is a third script. So yeah, bear with me. But literally all that's doing is it will just disable that Netwatch, and then it will run the internet check script, which Netwatch was initially doing itself. So now what Netwatch is doing is now running that first disable Netwatch script. So it goes Netwatch to that script, which then disables Netwatch and then runs the internet check script. But again, let's dive in and set this up. I'll show you. So I've got a very basic setup, just a HAP AX. I've got 2 networks. One's a PPPoE one, which is going over my Ether 1. So this is there you go. So it's going out of the Ether 1. It creates its own interface, and that's the actual one we're going to route traffic out of. It's done that. It's getting its IP address dynamically. And then I've got a second one, which is just connected to an LTE modem, and it's just a DHCP client. But again, we're not touching this one. We're not going to adjust this route, so that can just stay as it is. The one we want to change is this PPPoE. So what we'll do is we will, and I've just got a basic LAN, sorry, which the machine that I'm on is connected to, so we can run some pings and stuff from it. So the first thing we want to do is build our scripts. So we go System, Scripts. Now we're going to add 3, but let's add the 2 main ones first. Tick, don't require permissions, just so they can freely run. So we call this one first one iNet check, and then this one iNet check backup. So this is the one that initially runs when we have a initial failover, and this is the one that then run repeatedly once we're in a failed over state to fail back, hence the name backup. So what I'm going to do is I'm going to copy most of the scripts from here. So we want the first one, and then I'll show you what we need to change on it. So copy that, and I'm going to copy it into a notepad just so it's easier to edit. Okay, so that's the IP address we want to ping. That could be anything we like, provided it's something that we can reliably assume is going to be up. Now, the interface we're going to ping out of. Now, I should have mentioned this is those additional routes I had, those pinging to 8.8.8.8 of each interface. That's before I added this feature, or this parameter to the ping command. So this is basically going to ping 10 times, but you specify the interface you want to ping out of, which is what this is doing here. So we know that when we do ping, we are trying to ping out of our primary. So this is what's going to be our primary, which if we go back to our interfaces, is this one here. So we just copy that so we make sure we get we don't make any typos. Sorry, go back to change that to there. Now, as you can see, this is going to then set the route, and it's actually going to set a default static route that's added based on the comment. We would have commented that route as primary route. Now what I could do is go to IP routes. As you can see, these are both dynamic. I could go ahead and create myself this static one, but assuming that was like this one, for example, where we have a default gateway IP, that could change depending on my ISP, depending on, I could change, this is an LTE modem, I could change my 4G SIM card in there to a different provider. So then that would change and it wouldn't work. So I did have a, in my other guide where I talk about dynamic interfaces, I have a script that runs on the DHCP client, which then can then update this static route. But this is based on if you have a static route and then you create a comment, this would be primary route, and that's what that is checking against. However, our primary is going to be our PPP OE client, which gets it dynamically anyway. So the best way to get the right command to run is to open up a terminal, an interface, PPP OE client, set, because you can always, if you don't know, just tab it. So you can see it's set default route distance to be 3, and then tab again, and you can see you can actually select the name of the one you want. Okay, if you're not aware, so that is the command that we would want to run. That's going to set our route distance to be that. So we can change that one to there. Okay, we get the / just put input, make sure we're starting at the route directory. Right, okay, so as I mentioned, back to interfaces, under the dial out section, we specify this add default route with the distance of 1, so that was then going to update that to be 3. Okay, so the next 2 bits of our script are this bit we can now get rid of because we're going to run this differently. That's to disable Netwatch, and this is to enable that scheduler. Okay, so we can now go ahead and copy this into here. Okay, now we're going to do our backup one. So head back onto the website and we get the next script. Oh, no, I want to paste into here first, don't I? Sorry. BPP-1. And then next thing we want to do is we want to change that back to we update the basic route, but this time, as you can see, distance is going to be 1 because if the internet's back up, we want to set that default route back to 1. So this is basically saying it's pinging out of that same interface again, but this time, if it gets 10 still downs, so it's 10 failures, then it's still down. But then if it otherwise, it's assuming that it's back up. It's then going to set that distance back to 1, so we route all our traffic out of either PPPoE1. The scheduler, which was running, is then going to get disabled, and we're going to this time we're going to re-enable Netwatch within this script. Okay. Now I've got these log info here. I'll show you when we actually run it. It does actually generate quite a lot of login, which we don't necessarily want, but this is just handy to have when you're first setting it up. You can then go ahead and delete this afterwards because there'll be plenty of other logs in there to signify that you've failed over. Okay, so we now have our 2 scripts. Now we can add our scheduler. Okay, we go back down to here. Here's our scheduler. We can just copy this in and run this in the terminal. There you go. So it's added in, and by default it's disabled. Okay. Start time, as you can see, is 2021, so it's quite a long time ago, but it doesn't matter when it starts. It just means that it started in the past, so every 10 seconds it will be okay to run. Okay, so we've got our schedulers, we got our, actually I'm going to keep some of these windows open for when we do our testing, because then we can see what's being turned off and on. Schedulers are there. Like I mentioned, scripts don't actually, you can see the run count, but they won't go up and down, they'll always stay on. Now, last thing we do is our Netwatch, tools, Netwatch. Okay, now this one, again, we can just go ahead and copy it from here. But one thing I will do, just paste that in. Just want to disable that before we actually get going, because this is the thing that triggers everything. We need to add that 3rd script. So for that, we can just go to here, copy, okay. So as you can see, so now I'll go through everything again last time. So Netwatch runs, it tries to ping 8.8.8.8 every 10 seconds. If it gets a fail, so the down, it runs this. So it's going to run the script that's called inet disable netwatch, which runs this script here. This disables Netwatch, which is, we will enable that in a minute. And then it also then runs another script called inet check. Now inet check is the one here. This is then going to ping out of our primary, which is the PPPoE one. It's going to ping 10 times that same IP address to Google DNS. If it gets 10 failures, it's going to log that the internet's down. It's going to set the dynamic default route distance to 3 for that interface. and then it's going to enable our scheduler for the failed over. Then our scheduler is going to run every 10 seconds, a bit like the Netwatch, and it's going to run this script here. Now this script here, again, like the one before, will run our same ping out of that interface. If it gets 10 failures, it will say it's down still. Again, this logging can be removed afterwards, or you can keep it. It's entirely up to you. And then otherwise, it's going to assume that it's now back up because it's got the opposite of 10 failures, which is 10 replies. It's then going to change that default route, that dynamic default route, back to 1, and then it's going to disable that scheduler so it doesn't run this script anymore, and it's going to re-enable our Netwatch to monitor if we have any failures again in the future. Okay, so we can enable this. Now this should say up, and as you can see on up, nothing's going to happen. Okay, we still have, we go IP routes. Oh, they're over there. As you can see, my distance 1 is still set on my PPPoE. Let's bring up a terminal and let's do a trace route to the internet. There we go, we're going out my primary, which is my PPPoE network, which I'll just show you is on addresses. There we go, that one there. Okay. So let's get a continuous ping going. Okay, now let's disable my internet access on this one. Now I should just say this is actually routing over my development network where I'm running a PPPoE server. Now what I can do, that means I can actually, I don't actually have to shut the interface down. I don't have to kill the PPPoE, because as this is dynamic, if the PPPoE server goes offline or the next hop gateway or the interface shuts down, this is going to automatically get removed anyway. So our failure, none of this is needed, because this is automatically this will disappear. So this will become the highest or the lowest distance, should I say, default route. So what I've actually done is I'm just blocking any traffic from this network on my upstream router, so I can simulate should there be a failure somewhere in the ISP network that you can't actually monitor. If that makes sense. So I'll go ahead and enable my block rule, and then what's going to happen, see, my internet kit dies straight away. Now we're working on 10 seconds, so as you can see, that's now been disabled. That's been run once. What's happening? Our routes are changing around. There we go. And now failover's happened. So as you can see, this is now still on 2. This is now gone to 3. Now that disappeared. Now the reason that disappears is because PPPoE were basically affecting the connection itself. So every time I make a change to the actual interface connection, it will re-establish each time, which is why it's doing that. But there's nothing more to it than that. So as we can see, we've failed over. Now this is going to be, so this is already run 3 times. As you can see, it's now run that script 3 times. That'll probably go up to 4 in a minute. Now you may say, well, that's quite a long time to fail over, which might be fine for your home or whatever, but all we need to do is just adjust those times basically. With 10 seconds here, we're also then waiting for 10 pings to happen. So we could either speed up the speed of the ping, or we could, shorten that number to say 5 and just play around with those, those different numbers, just to try and bring that window down if it's something that's of concern. Should also say we get our logs open here, and this is what I was saying, where it's continuously going to keep logging this. So if we're down for a period of time, our logs are going to fill up quite quickly with just this. As you can see, this is what happened. If I just freeze that, when we first of all, so was when we first enabled it, so event up, then it went down when I made that change to the upstream router. This is the Netwatch triggering the script. It then logs it being down from that script. This is where I mentioned the PPPoE will actually terminate because we're adjusting the settings on the actual connection. Netwatch gets disabled, scheduler gets enabled, PoE connects, OE connects, and then we're then running this down script, which is now run 12 times. Okay, so now what I'm going to do is unfreeze that. There you go, 12 logs now. Let's revoke what I did before and actually allow internet access from that PPPoE. So we're bringing the network, the primary one, back on, and then watch what happens. Oh, there we go. Flicks back. That's now been turned on. This has been turned off. That won't get run anymore. If we look at our, there we go. A couple of drops, but we're back up. So it's obviously a lot quicker to fail back because we're not waiting for a failure to trigger anything else. So let me just show you that one more time. So let's just block the upstream route. There you go. So I don't actually kill this connection. This connection stays up. The only reason it drops in and out is because we're actually changing the menu, the options in that connection. So that comes back, and now it's back to 3. Then we're back online. So we lose about 4 packets, which isn't too bad. You might get a bit of a blip on your VoIP call. Your web page might take a few extra seconds to load, but I wouldn't think it'd be anything majorly noticeable. Obviously, if you're then failing over to a much slower connection, you may then notice you failed over. But you know, you plan for that. If it was critical, you'd have something that was more reliable than just a 4G potentially slower connection. But there we go. So hopefully that was clear enough. It's like I say, it's simplified it a lot to how I originally had it. I was overcomplicating it. You may say this is still complicated enough, but once you get your head around it, you just need to make sure that everything's running in the right order and you've got the right things enabled or disabled to begin with. Like I say, if this wasn't a PPPoE, then you had a static route or even a DHCP client. As you can see, this is my modem one. You would then basically just run the whichever command you needed to adjust that distance here, would just then change. So this time it would be IP DHCP client set, and then just obviously tab default route distance to be 3, and then if you tab again, you can actually put the name in like that. Okay, so yeah, and then you just copy and paste and put that in there if your primary connection. So you basically just have to work out whatever the CLI command is to do it, and then obviously update this being the interface which you want to ping out of, which would then be whatever this is here. Okay, so yeah, try it out. Any questions? If you have used the previous one and you haven't, and you've spotted the issues and you hadn't commented, feel free to comment again and to say it's working now. Thank you to the guys that spotted this out. Thanks for watching, and if you've got any more comments or requests for videos, please reach out. I'm always happy to speak to people, help people produce videos that will help, or things people need. If not, I'll see you on the next one. Thanks.